So this is the hopefully last part of section 3.2. It ends, we're just going to continue finding domains and ranges from graphs until we get done with the graphs. And then we'll do some domains and ranges given function equations. So for problem 26, both edges are marked with solid filled in dots. This is an easy domain and range. I don't have to extend the graph because both the edges are labeled. The left edge is going to be at the point negative 2, 6. So my domain is going to start at the point negative 2, 6. Its x coordinate is negative 2. And my domain is going to end at the x coordinate of 1. Double square bracket because each of the points is marked with a closed circle. For my range, I need to figure out the bottom. That's the bottom of the graph. My range is going to start at y equal negative 3. There's the top of my graph. My range is going to end at y equal to 6. Double square bracket because the points are marked with closed circles. So range negative 3, comma 6. Finally getting to some open circles. So for 28 as well as 27, graphs don't need to be extended because the edges are marked. In terms of the start of my domain is going to start right here. I have 2 points that aren't labeled here, but it's the point negative 2, positive 2, and the point negative 2, negative 2. My domain is going to start at x equal negative 2. That's the left edge of my graph. And I'm going to get a round bracket because the open circle. This point here wasn't marked, but it's the point 2, 0. That's going to be the end of my domain. And unmarked points on the graph get square brackets too. Only infinities and points with open holes get round brackets. So my domain is going to be round bracket negative 2 because both of those 2 points are open circles. They have the same x. My x for my domain is negative 2, open circle because of the round bracket. Then my x for the end of my domain is positive 2. Points that are unmarked points on the graph get square brackets. In terms of my range, the bottom for my range is going to be this y equal to 2. Or the start of my range, y equal to negative 2. The top of my range, or the end of my range, is going to be y equal to positive 2. Both of those points that begin and end the range have open circles, so both parentheses are going to be round parentheses. I'm going to get round parentheses negative 2 for that y, round parentheses positive 2 for that y. So the domains and ranges, they don't have to have parentheses that match up. It can be completely random. You just have to know which style of parentheses is appropriate. So this graph doesn't need to be extended. They're my favorite kind. This point right here, it's the left edge. It appears to be the point negative 3, 0. I'm going to start my domain at x equal negative 3. And that point right there, which looks like the point 5, 11, which has an x equal to 5, will be the end of my domain. When I go to write my domain, the numbers are going to be -3 first and then 5 second, because the x-coordinate of the leftmost point is -3, the x-coordinate of the rightmost point is 5. The -3, because it comes from a point that's marked with a solid circle, gets a closed bracket. The 5, because it comes from a point marked with an open circle, gets a round bracket. When I go to do the range, this is the bottom point, so my range is going to start at y equal to 0. And this is the top point. My range is going to end at y equal to 11, because I go bottom to top and I pick off the y's. So the numbers for my range are 0, 11. This point was marked with a solid circle, so I square bracket. That point's marked with an open circle, I round bracket. No extensions needed on 31, no extensions needed on 32. The edges are marked. There's nothing that implies that the graph goes on forever. So for 31, this point there is going to be the start of my domain. It's the left edge. So I'm going to start my domain at x equal to -3. That point's the right edge. I'm going to end my domain at x equal to +3. So when I go to write my domain, the beginning number is -3, the ending number is +3. I get a square bracket on the -3, a round bracket on the +3 because of the closed and open circle. For the range, this point's the bottom of the graph. This is going to be the start of my range, because it's lowest point, and it's going to start at y equal to -2. This point's going to be the end of my range because it's the highest point. It's going to be y equals to -3. That's y equal to +3. It can't be -3. Oh, my eyes were playing tricks on me. So for my range, the starting number is going to be -2. The ending number is going to be +3. That point's marked with a solid circle, so the -2 gets a square bracket. That point's marked with an open circle, the +3 gets a round bracket. Both of our graphs, 33 and 34, need to be extended, and well, they are what they are. 33, I'm going to extend my graph this direction, and so for my domain, I'm going to get an x equal +infinity because it's going to the right, and this extension for my range is going to give a y equals +infinity because it's going up. I start my domain right here because the left edge of the graph is marked, so I only get to extend the right edge. And in terms of a point, that looks like it's the point -4, +3. So my range, my domain, is going to start at x equals -4. It's going to end at x equal infinity. Round bracket on the -4 because of the open circle. Infinities always get round brackets. For the range, my range is going to start right there. That horizontal line is going to be the start of my range. And every point on that line has a y equal to 1. There's the point 1, 1. There's the point 3, 1. So the start of my range is going to be y equal to 1. And the end of my range is going to be up here. It's going to be at the infinity. I always can tell the infinity that I'm going to need. So for my range, the numbers I need, the starting number is going to be y equal to 1. The ending number is going to be y equal to infinity. Infinities always get round bracket, and every one of these points is either marked with a closed circle or it's an unmarked point on the graph. Closed circles get marked with a square bracket. Unmarked points on graph gets marked with square brackets as well. Lastly, problem 36 needs to be extended. When I extend it for the domain, it's going to go to x equal positive infinity because it's going right as it's going down. For the range, it's going to give me a y equals negative infinity because it's going down. I need to know these 2 points. Here, I think this is a point, I can't even tell what that point is. This is a crappy graph. Clearly I picked this off of Google Images. I just learned how to do make these graphs by myself, so I don't have to steal them from analyzemath.com anymore. I can't tell what the y-coordinate of this point is, but it doesn't matter. This point A is the point -3 comma some unknown number, but doesn't matter what that unknown number is because the start of my domain is just the x-coordinate, which is x equal to -3. So for my domain, starts at -3, ends at infinity. For problem 36, starts at -3, ends at infinity. This point's marked with an open circle. Infinity gets a round bracket, I get double round bracket. My range is going to start at the bottom. So the start for my range is going to be y equal negative infinity. That's the bottom of the graph, and the y I know is negative infinity. This point's the end of my range. This is the end of my range. It's going to be a square bracket because it's a marked point on the graph, and that looks like it's the point -2, +2. I need the +2 part of it, the y-coordinate for my range, and then infinities always get round brackets. This 2 gets a square bracket because it's an unmarked point at my graph. One more before we get to a new kind of problem. 38 needs to be extended in both directions. This direction right here, for my domain, it's going left. So the left extension for my domain is going to extend to x equal negative infinity because it's going left slower than it goes up, but it is going left, which means it eventually will get to the far left edge of the x-axis. This extension is going up. So for the range, I'm going to need a y equals positive infinity. This graph, this side also needs to be extended. And for the domain, it's very slowly going right, but it's going right, and the right direction on the x-axis is positive infinity. It's very quickly going down. And for that extension, it's going to be y equals negative infinity. I'm not going to get anything but infinities. These points right here are distractor points. That point 0, 0 is not the very bottom of the graph. It's not the starting point of the graph. The point 2, 4 is not the very top of the graph. They're just distractor points that are marked. So both my domain and ranges have to have the infinities from the extensions. The domain's going to go from the start in negative infinity to the ending positive infinity. And the range is going to go from the starting negative infinity to the ending positive infinity. And that's all there is for that. Next kind of problems, we need to find the domain using algebra without actually having a graph, but I could graph some of these and it won't be that particularly hard to see the domain. Not finding the range. Range is kind of a calculus question when you have functions. Let me just show you the graph for problem 40, and so you can figure out what the domain is from the graph. I'm going to enter second square root of x minus 3. Have that nice window set up. I'll sketch a graph. This graph is going to look something like this. That x minus 3 kind of comes up right there on the x-axis at positive 3. That's what the graph looks like. And very specifically, this is the point 3, 0. How am I going to write the domain if I have the graph? Well, it's pretty darn easy. This part right here, it's going to extend. And for the domain, it's going to extend to x equal positive infinity. For my start of my domain, it's going to start at x equal to 3. This is actually a point that would be marked with a solid circle if I did the graph by hand. The domain for this is going to be 3, infinity. The algebraic way to get it is not particularly hard. Algebraically, to find the domain, if you didn't want to do a graph, you just take the radicand without the square root, set it greater than or equal to 0, and isolate the x. In this case, I'll isolate the x by adding 3 to both sides. Algebraically, I get the domain as x is greater than or equal to 3. That's what this means. These things are equivalent to each other. Saying the domain is square bracket 3, infinity means the domain is all numbers x greater than or equal to 3. So algebraically, we're going to get a symbol that with a greater than or equal to sign, and greater than or equals to turns into brackets that have a number with a square bracket on the left side and a positive infinity on the right side. So to find the domain of a square root without a graph, all I do is take the radicand and I set it greater than or equal to 0. So for problem 42, if I wanted to find the domain and I didn't want to graph it, the algebra to find the domain of a square root is to take the radicand, set it greater than or equal to 0, isolate the x by doing whatever algebra that's necessary. In this case, it's subtracting 10 and dividing by 2. Get the inequality, in this case, x is greater than or equal to -5, and then write it as an interval. As an interval, a greater than or equal to is that number, infinity. Infinities always get round brackets, and or equals to's turn into square brackets. This would be the domain for 42, which means if I would graph this, the graph is going to start at the point -5, 0. The beginning of my domain is going to be x equal to -5, and the end of my domain is going to be x equal to infinity, just so I can show you on a graph. If I did y equals second square root of 2x plus 10, you'll see this graph. It starts at -5, goes off forever to the right. The starting part of my domain is -5, and right there it's an unmarked point on the graph, so it gets a square bracket, and my domain goes forever to infinity. The next few problems we do in intermediate algebra, and I think we do in college algebra prep, I kind of forget, and it's finding the domain of a fraction. This could be a little bit tricky. Let's do 43. I think it's a better problem than 44. So if I wanted to find the domain for 43, this is a little bit different graphically because the graph is broken. The graph for this, let me see here. I think the graph is going to look like this. Let me graph this on my calculator real quick. One of these dashed lines that I just drew in, and it'll actually go more like that. This graph has 2 halves. I can't write the domain with one interval because the halves aren't connected. I have to describe this half with an interval and that half with an interval to describe my domain. And let me just show you graphically what this looks like. So let me graph parentheses x plus 2 divided by parentheses x minus 3. I get a left half and a right half. I need to describe the left half with a single interval, the right half with a single interval. It's not actually that hard to do, but it's different than anything we've done. It turns out that the halves are split on either side of +3. This left part of the graph, it goes from the far left edge of the x-axis. So for this left half of the graph, it's going to start at x equals negative infinity. It goes through 2 on the x-axis, actually negative 2 on the x-axis, blows right past this and gets to a break. And where does it break? It breaks at x equal to 3. So this left half, it's going to start at negative infinity, which will always get a round bracket. It's going to end at x equal to 3. And because there's no point on the graph that has x equal to 3, it's technically proper to put this in a round parentheses. There's no point on the graph that has x equal to 3, because if I plug 3 in for x, I get undefined. And if you plug a number into a function and get undefined, then that value, that number when shown in the domain, needs to get a round bracket. So the left half of the graph goes from negative infinity to 3. The right half of the graph is going to start at right after x equal to 3, and it's going to end at x equal infinity. So the right half of the graph starts at x equal to 3, ends at infinities. Infinities always get round brackets, and numbers that make denominators of fractions of zeros always get round brackets as well. This is technically the domain for problem 43, meaning I did it with having a graph and I knew what the graph was going to look like. I knew where the break was. That's not how we're going to do the domains. You don't need to sketch a graph. In order to find the domain of a fraction, 2 things. By hand, I need to ignore the numerator. The numerator doesn't give you a place where the graph breaks. It actually, if you set it equal to 0, it gives you an x-intercept, which has nothing to do with the left edge of a part of the graph or the right edge of a part of a graph. Algebraically, I'm going to solve the denominator equal to 0. So in problem 43, I'm going to go x minus 3 equals to 0, do the algebra, and get x equal to 3. So this is the algebraic way to find the domain. Next, I'm going to create a number line with negative infinity on the left, positive infinity on the right, and this number between. So number line, that hardly looks like a line. Negative infinity on the left, which represents the left edge of the x-axis. Positive infinity on the right, which represents the far right edge of the x-axis. And then the 3 between. Add round parentheses and create intervals. So I don't have to know what the graph looks like to be able to write down the domain of a fraction. So I created round parentheses between the negative infinity and positive 3. That represents that interval. I made round parentheses between 3 and infinity. That represents that interval. Usually when the graph is broken up into halves, or maybe even 3 pieces, we put this little U symbol between the intervals, which means union or. If you don't write that between, it's not such a big deal. I just instinctively did it without even thinking. So another finding the domain of a fraction, and I'm not even going to graph it. I'm just going to use my strategy to find the domain of a fraction. I ignore the numerator. In this case, it's x equal to 5. I solve the denominator equal to 0. In this case, that's x squared minus 5x plus 6 equals to 0. I'm going to solve by factoring. Again, if you're cruddy at factoring, it comes up a lot in our class. You should watch my Math 120 Intermediate Algebra video, section 1.3, part 2. That will teach you the most basic factoring that we do the most. This actually factors into x minus 2 times x minus 3, because the numbers that go after the x's need to multiply to positive 6, and negative 2 times negative 3 multiplies to positive 6. They need to add to positive 5. Negative 2 plus negative 3 adds to positive 5. If I have something factored and set equal to 0, I have to split the factors apart. Set each one equal to 0. I get two answers. There's actually going to be two breaks in this graph, and the graph will actually have 3 separate panels. I'd need 3 separate intervals. So I'm going to create now a number line. And on it, I'm going to have negative infinity, positive infinity, and then in the correct order, the numbers 2 and 3 that I just came up with. So there's my number line. Negative infinity, which represents the far left edge of the x-axis. Positive infinity, which represents the far right edge of the x-axis. 2 comes before 3. Doesn't matter where I put them. Now I'm going to add round parentheses. And create my answers. So between every number, I'm going to get a round parentheses. So the domain for this is going to have 3 intervals. The graph would have 3 separate panels. One would go from x, the far left edge of the x-axis, then there'd be a break at positive 2. Then from the break at positive 2 to a break at positive 3. And then from the break at positive 3 to the right edge of the x-axis. That's the domain. It has 3 separate intervals. Usually I put union symbols between. One last kind of problem, which is so easy that students mess it up all the time on the test, and they lose like 6 points because they don't remember the trick. So last group of problems are polynomials. The first functions that I graphed were square roots. Second were fractions. Here's a polynomial. Let me show you the graph of 48. Let me sketch a graph of y equals 2x minus 10. Oh, goes way off my screen. Looks something like this. I'll make my window a little bit bigger. I wonder if I just hit zoom out. Go zoom and hit out. See what I get. Hit enter. I don't know how to do this. There, I made it bigger. So it looks something like this. I've never really done that before. But here's my graph. It goes off the screen to the left. It goes off the screen to the right, which means the graph needs to be extended. My edge here is going to give me my start for my domain. Because this is going left, the start of my domain is going to be x equal to negative infinity. This edge is going to give me my end for my domain. Needs to be extended because there's no end to this graph. And it's going to end at x equal positive infinity. So in terms of left and right edge, this is going to be negative to positive infinity. The domain for 48 is going to be negative infinity to positive infinity. If you do algebra, the algebra that you might do might get you the 0.50. It will give you the x-intercept if you set 2x minus 10 equal to 0, but it won't give you the left edge of the graph. You won't give the right edge of the graph. The rest of the problems, 47, 48, 49, 50, probably 51 and 52, these are all called polynomials. Some of them are lines, some of them are parabolas. All polynomials will have a domain of negative to positive infinity, there's no algebra required. And if you do algebra, you're likely going to find an x-intercept, which has nothing to do with the left or right edge of a graph. The algebra is going to take you way in a bad place because it's not going to give you the left edge, the start of the domain. It's not going to give you the right edge, the end of the domain. It's just going to give you an x-intercept, which has nothing to do with the domain. Let me graph 50 to show you that it has the same domain. 50 is a polynomial. It's a parabola graph, but the domain for all polynomials require no algebra whatsoever. Each of the problems that I'm going to finish up with is going to have the same domain. Here's x squared plus 5 graphed with my expanded window. I have no idea. That seems reasonable. So this graph looks something like this in my expanded window. If I did zoom standard, it might look a little bit different. But if I'm going to find the domain, I need to extend this. And the start of my domain is going to be the x from this extension, and that's the left direction, which is going to be x equal to negative infinity. And this direction is going to be the end for my domain. The y direction is positive infinity, and as well as the x direction. If I did any algebra, I don't even know I'd get. I'd probably get an I if I did the algebra right. This is a polynomial. I don't need to graph it. I don't need to do any algebra. The domain is just going to be negative to positive infinity. Similarly, the last two problems, if I graphed them, if I graphed like y equals to x squared plus 2x minus 15, I don't even know if it's going to show up. If I graphed it, it's a parabola. Graph looks something like that. The left edge, the start for my domain, has to have the graph extended, and it would start at x equal negative infinity because that's left on the x direction, which is negative. This right here is going to be the end of my domain, and that's the positive x direction, which is positive infinity. Each of the problems at the very end of this section, they're polynomials, and all polynomials have domains of positive to negative infinity. If you do any algebra, you're likely going to find an x-intercept. If I did the algebra here, set it equal to 0, I'd get that x-intercept and that x-intercept, which have nothing to do with the left and the right edge of the graph. They don't belong in the answer for my domain. So that's the end of 3.2. Most of it was just stuff from other courses, except this might be new to you depending on the last class that you took.